Hey everyone, welcome to day 27 of Math 133. We are going to be talking about the Chapter 11 review today. That is on page 563 in your course pack, page 563. And it is 6 pages, so make sure you grab all 6 pages, okay? Page 563. Um, so this assignment is due on Thursday. But if you want to turn it in late, that's okay. I'll take 1 point off for each day that is late, up until May 1st. After May 1st, I am not going to be able to grade it because um, all assignments need to be turned in by then. Okay, so you have until 11:59 p.m. on May 1st to turn it in. So if it's turned in after that, uh, for any assignment, that's it. You're out of luck. Okay. So make sure you get everything turned in. We're going to be looking at the sample final exam starting this upcoming Thursday, and we're going to be working on that together in class. Me and then Cindy and Elaine, they'll also cover some parts of it. Okay. Um, but if you really want to study for the final exam and like really focus on studying, the best thing to do is try doing the sample final exam on your own first before Thursday, okay? Because the sample final exam covers the same kind of questions that you're going to see on the final. And it also covers everything from chapters 1 all the way up through 11, okay? So, unlike the cumulative reviews, which, they've covered quite a lot, but this one covers everything, okay? So try the sample final. Don't turn it in. Come to class after you've done the sample final on your own, and then you can see if what you did was correct, because we're going to go over it together in class starting on Thursday. And you can see if you got it right or not, and then if you got it wrong, you just change it, right? And that'll point out the places that you need to study more. Okay. Um, if you try the sample final exam on your own and you get stuck on something, again, we'll cover it in class, but it's again going to point out the places that you need to study more. So, like if you come to class on Thursday with the sample final exam blank, we're going to work on it together, and you'd be like, oh, yeah, I remember how to do that. I remember how to do that. Okay. But memory is a weird thing. Sometimes when someone reminds you how to do stuff, so as I start giving you hints and stuff, you're like, oh, yeah, yeah, I know how to do that. There's no hints on the final exam, right? You have to remember it from nothing. So it's here's your blank paper, here your blank final exam, and you're like, oh shoot, we covered this. I don't remember how I start, right? So I don't want that to happen. Try the sample final on your own if you really want to study and do well on the final, okay? Um, anyway, this is just a suggestion. Today, by the way, is the start of week 14. And so if you're watching this on Zoom, then you don't have to do any more discussion boards. There's not going to be a discussion board next week. Okay, so you do not have to come to class next week. You do have to take the final, but you don't have to take it with me necessarily. You can take it at the testing center, right? So you don't have to come to Zoom starting next week. So if you are watching this on the recording, and you miss the Zoom this week, this Tuesday, today, and you miss it on Thursday, then you do have to do this one last discussion board. Okay. Speaking of the testing center, if you're taking it at the testing center, make sure you bring your picture ID. It can be a driver's license, it can be a passport, it can be your student ID, as long as your face and your name. But if you come to the final exam and they have no way to tell that you are who you say you are, you can't just take the exam for someone else. Okay, so you have to bring that. Um, all right. So covered all that. Okay, I think that's everything. So, in Canvas, if you click on the Chapter 11 review, there is a link that'll bring you to our data sets for all of our different worksheets, and you'll have to scroll all the way to the bottom to get to the Chapter 11 review, which is right here. There's a link for StatCrunch, and if you click on that, it'll bring you to this data set, which I'll drop in the chat for you, so you don't have to go find it. But if you're watching it on Zoom, you'll need to get that StatCrunch link, okay? So you would get it from by clicking on where it says this link, okay? And then page 563, okay? Chapter 11 is all about having two samples, okay? Everything that we've looked at so far, so when we were looking at hypothesis testing for a single mean, that was when we had one sample. Or if we were looking at confidence intervals, that was looking at, we've got one sample, so confidence interval for a single proportion, right? Now we're looking at two samples. Now those two samples could be from two different populations. Like I have a bag of Skittles and I have a bag of M&Ms. Those are two different populations, and we're trying to compare if those two populations are similar. Or those two samples could be from the same population, but if they're from the same population, they either have to be independent or strictly dependent. So independent would mean that they don't share anything. So with M&Ms and Skittles, there's no candy that's both an M&M and a Skittle at the same time. Okay, but if I was looking at like the average height of people in the U.S., I would do a random sample, and if I did two samples, I would need to make sure that there was nobody who was in both samples at the same time. Okay. Um, or you can do dependent, and that's called matched pairs. And when you do that, you are comparing two samples where it's the exact same people in both samples. Okay. So anyway, in chapter 9, we talked about confidence intervals, we talked about sample sizes, and then in chapter 10, we talked about hypothesis testing. So chapter 11, we're going to combine all of that. And so that's why you've got your chapter 11 flow chart. So make sure you have that handy, because you can take that with you to the final exam. And that's going to help you figure out, okay, do I have one sample? Do I have two samples? Are they matched or not? What stat crunch buttons do I click on? What page do I find this information? Okay.
Joe, I
All
have a
right.
question about that, about the
Sure.
flowcharts.
Go ahead, Gabby.
It's just that there
Yeah.
was so much to write on there for the flowcharts. I just wanted to know when the flowcharts are going to be graded, because I kind of want to, like, I already turned them in, but I want to redo them so I can be able to read them for the final.
That's fine. You can redo them. You don't have to resubmit. So um, I will be grading. I'll be doing a ton of grading this upcoming weekend to try to make sure that I've got as much graded for you guys to study off of as possible. If there is something specific like you're asking right now, the flowcharts, if you're like, no, I really want that graded so I can study off of it, I'll make that a priority. So I will put chapter 11 flowcharts at the top of the list. So that'll be the next thing I grade. Um, okay, sounds good. So, um, all right, so let's start on page 563, and we're gonna give you some hints on stuff. So in 2024, 40% of adults in Michigan and 38% of adults in Wisconsin identified as Republican. You want to conduct a study to see if the difference in these percentages have changed. So this was back in 2024. Now we're coming up on the midterm elections. You want to see if those numbers are different now. How many adults in Michigan and Wisconsin do you need to sample in order to correctly gauge the difference? 95% confidence, blah, blah, blah. So we need the formula, the substitution, and we need the result, right? Now, what page in our exam notes packet, our yellow exam notes packet, should I be looking at? Because this exam notes packet is huge. And when you are on the final exam, I don't want you to have to spend time flipping through looking for it, right? So that's what the flowcharts is supposed to help with. So I also recommended that you write on your 8.5 by 11 piece of paper what is on each page, so that just write it in your own words. So like page 260 is confidence intervals for two samples, right? So, or however you want to word it, so that it's helpful for when you come across a question like, okay, I know which page to look at. So I'm going to ask you guys to help me with the hints. What page will I find this information on? Mike says 261. Does anybody agree or not? Yes. So page 261 is how many? And for single samples, we have these formulas, but down at the bottom, we have sample size formulas when you ask a how many question. So how many adults uh, for two, so double population, okay? So in this case, it's page 261 at the bottom. All right. How many, so we're asking how many again, adults in Michigan and Wisconsin must you sample? So this is also page 261 at the bottom. Okay. Let's see. So question number 4 down here. Circle true or false after each statement. Explain why if it is false. Type 1 errors are always worse than type 2 errors. True or false? Gabby says false. Ryan says true. Think someone to break the tie for me. Mike says false. Uh, okay. Well, if it's false, you have to explain why. So why is it? So is it that type 2 errors are always worse than type 1? Did they put it in the wrong order? Why is it false? I agree with you. Why is it false? Mike says it depends on the context. Yes. So, what does that mean? It means it depends on the real world situation that we are talking about. Sometimes type 1 is worse. We've seen cases of that already. Sometimes type 2 is worse. We've seen cases of that as well. And sometimes they both suck. We haven't seen a case of that. So I'm gonna pause right here and we'll talk about that real quick. So let's say um, this let's say that you are going to be in the Olympics, right? Um, in order to be in the Olympics, they do drug testing on all of the athletes to make sure that they're not using steroids or performance enhancing drugs. Okay. And those tests are a hypothesis test. When you are doing that test, it has some sensitivity level. It's not going to be 100% accurate. Okay. Why is it not going to be 100% accurate? So if uh, so I'm going to draw, a sample of their blood and test it and see if the steroid level is normal, because humans have steroids. You naturally produce them. The question is whether you're at a normal level or whether the alternative hypothesis is true, which is that you have more steroids than you should. Okay. So you can't test the entire population. What is the population? The population would be all of that athlete's blood. You can't drain the athlete of all of their blood and test it. Okay. So you're going to do a random sample. You're going to do a blood sample. Okay. And so you are hopefully, this test is 99% accurate or 95%, or maybe it's 99.99% accurate, but it's not 100. Okay. So in reality, if the null hypothesis is true, then that means that the athlete is not on steroids, right? They haven't taken any performance enhancing drugs. If the if the null hypothesis is not true, then that means that they are on steroids, correct? No, you do not have to rate this, Jadelyn. Sorry. I'm off on a tangent. So, but I want to illustrate this. So, we don't know which one is true. We can't know. Okay. But we still have to make a decision based on what our test tells us. So if our test tells us that the to not reject, then that means that the decision that the Olympic Committee makes is that they will let the athlete race, correct? Let them race. If you reject the null, then that means that we believe that their steroid level is too high, and that means that they do not reject. So, no. If we do not reject, we will let them race because the null hypothesis is that their steroid level is at a normal level for an adult. Okay. So if we reject the null, then that would mean that we accept the alternative hypothesis, which is that their steroid level is too high. And in that case, they do not get to race. Okay. They're disqualified. So we've said before that these are correct. And we said that this is type 2 and this is type 1. The question for you is which of these errors is worse, type 1 or type 2? Which error is worse? What do you guys think? Gabby says type 2, Raya says type 2. So what is type 2? Type 2 is that this athlete is on steroids, but gets to race. And that's not okay, right? Because that means they have an unfair advantage. They're cheating, right? This person is on steroids. We still let them race, okay? Maybe they get a world record and that world record is not accurate, right? So everyone kind of agrees type 2 is bad, okay? Well, what about type 1? What does type 1 look like? Type 1 is that the athlete is not on steroids and they do not get to race. Yep, not on steroids, but doesn't get to race. I argue that that is also bad because think of it from the athlete's perspective. This person has been working for 4 years and they have been training. They've been, watching their diet, not eating like pizza and pop and stuff like that. They've been working for this and they get to the Olympics and this blood test says, sorry, your steroid levels are too high. You don't get to race. You're disqualified. This person is not on steroids. They haven't been taking it. They know they haven't been taking it. Okay. Not only that, this is going to get out, right? That this person got disqualified. If that gets out, maybe they have sponsorship deals that they're going to have taken away, right? This person, maybe their world records or their previous medals get taken away. Okay. This is terrible for that person. It's going to, probably ruin their lives, right? So type 1 is sometimes worse. Everybody said so far type 2 is worse on this one. And yeah, I would agree type 2 is bad in this case as well. But sometimes they both suck. And this would be an example where you you kind of need to avoid both of them, right? So anyway, Gabby thinks it's even now. And that's all I was trying to point out is that, you know, sometimes it's obvious that yeah, type 1 is way worse. Sometimes type 2 is way worse. And sometimes they both suck. And in order to deal with that, you have to make sure that your test is accurate. You have to do multiple tests. And that's what they do in the Olympics is if you fail on one test, you're not just out. They will test over and over and over. Okay. So anyway, sorry for going off on a tangent. You guys know I do. Let's go back to 4B. Um, a p-value of 0.505 is more statistically significant than a p-value of 0.10. What do you guys think on this one? True or false? Mike says true. Same answers, different answers. Everybody agrees. Yeah, yeah, you guys are right. All right. Next page is page 564, and a new post-surgical treatment for a common surgery is being compared with a standard treatment. 7 patients received the new treatment, 7 patients received the standard treatment. Here's the recovery time. So after the surgery, recovery time is how long it takes for them to, get better and, be able to leave the hospital and go back to work, right? So verify the conditions to construct a confidence interval are shown. So we have to check that it's random. And we need to check that. So we have 2 samples here. For these 2 samples, we can either have them be independent of each other or dependent of each other, meaning these are either independent, where it's different groups of people, 2 different groups measured once, or it's dependent, where it's the same people measured twice. Okay, so in this case, it's independent. Okay, because you're not going to have the surgery, you're not going to have someone do the surgery and then go and do the surgery again, a different way, right? So independent. In this case, it's 2 different groups measured once. Okay, and that's you have to check that, but you also have to check that it's each of these is independent of the population. Okay, and lastly, you have to check that each of these is normal. Okay, if all of these are yes, then that means you can construct a accurate confidence interval. On test day, if one of them is no, I want you to still construct the confidence interval, but in real life, you have to have them all be yes in order for it to be an accurate confidence interval. So for part C, I just want you to write out the StatCrunch path. You don't have to actually show the work, and then give your result. Now, where is the StatCrunch path? So what page do I need to look at for this in my exam notes packet? Because I need to know what StatCrunch buttons to hit. So Crystal says 266. Mike says 260. Anyone have a different guess? 261. So we've got lots of different guesses, which illustrates why it's important that you have your flow chart and why you have something written out so that you're not having to flip through and find the page. Okay. So first of all, are we looking at means or proportions? We're looking at means, averages. Okay. And we have 2 different samples. So page 265 is if you have matched pairs. That's if you have dependent samples. That's not what we have. So Crystal's got it. Page 266 is, no, sorry, we don't want hypothesis testing. Oh, wait. We want to construct a confidence interval. So that's, where is confidence interval? Page 261 is sample sizes. Here it is. Page 260. That's what we want. Page 260. Page 260 is confidence intervals, and this is proportions, matched pairs. We have, in this case, independent means, so we want what's at the bottom of page 260. Bottom of page 260. This will help us build a confidence interval for 2 independent means. And the StatCrunch is right there. All right. See, I even confused myself. So yeah, important to have a working flow chart that you can uh, look at and figure out where you need to go. All right, page 565 now. A simple random sample of US adults marked on a program of regular aerobic exercise. Their heart rate Rates in beats per minute were measured before and after with the results at right. Verify the requirements are met, so we need random. Now, here we can write that it's independent or dependent depending on whether we have independent samples or dependent samples, in which case it would be this one group measured twice. So in this case, do we have independent or dependent samples? Is it two different groups measured once, or one same group, one group measured twice? Which one is it? Yeah, it's one group. So this is dependent. One group measured twice, before and after, right? So independent is you have two samples where there's no overlap. Nobody is in both samples. Dependent is where, so for a dependent sample, you need to make sure that it's perfectly overlapped, meaning everyone is in both the before and after group. So you can't have a random sample where one of the guys, so Jack comes in, you measure his heart rate, and then he leaves for the day and doesn't stay for you to measure his after results. If that happens, then you can't use that sample because uh, that means that it's going to bias it. Okay. So you got to measure everyone twice. All right. Independent of the population, we got to check that. We also have to check that the two samples are normal. Sorry. It's the, yeah, okay. So this in this case would be matched pairs, and we are building confidence intervals. So this is page 260 in the middle, confidence interval for matched pairs. Okay. All right. Page 566. In a randomized double-blind clinical trial of a new vaccine, rats were randomly divided into two groups. Subjects in group 1 received a control vaccine. Subjects in group 2 received the new vaccine. Researchers found that 19.4% of the 500 subjects in the control group experienced fever as a side effect. 25% in the experiment group experienced fever as a side effect. So we are doing a hypothesis test. So what page in my exam notes packet should I be looking for this? Because I'm going to need the StatCrunch buttons that I need to click, right? Yeah, it says page 266. So first of all, are we measuring means or proportions here? We're measuring proportions, yes. So if we're measuring proportions and I have two different samples, I'm doing hypothesis testing. I need hypothesis testing for two proportions. Now, we don't have one for dependent, we just have independent. So this is page 264. Okay. So there's all the StatCrunch that we would need for this in order to do this one. I think that's all the hints on that page. Just that one. And then next page, page 567. A researcher for Consumer Reports believes that SUVs have worse gas mileage than sedans. They gather a random sample of both types of vehicles, measure their gas mileage, and conduct a test. And the results are already given to us here. So you don't need StatCrunch for this, right? So in this case, explain why this is an example of independent sampling. So independent means that the two samples have no overlap. There's no car that's in both samples. Well, that makes sense because a car cannot be in both samples because a car cannot be both an SUV and a sedan at the same time, right? So it's not possible for there to be any overlap. So these are independent samples. Okay. So Gabby wants to look at this. Let's uh so Colin Corbin says that yeah, don't forget about crossovers, right? But anyway. Okay, so what type of test is this? Gabby says that this is a left tail test. I agree with that because this is a less than. So it's a left tail test. How many SUVs were sampled? 29, right? And you can see that right there. What was the average gas mileage for a sedan? Um, That's the standard deviation. I want the average gas mileage. There we go. This one right here. This is the mean, which is average. Mean sedan gas mileage, 21.667. Okay. And then down here, use the computer output. Just do steps 4, 5, and 6. You do not have to do everything. Okay. Because it's already done. Right. Here's step 1 is right there. Step 2 is right out what your alpha is. Yeah, it's all done. All right. Last page for hints, and then we'll go back and we'll fill in what we missed. A company studied 2 programs for compensating its sales staff. 9 random salespeople participated in the study. In program A, the salespeople were paid a higher salary and a small commission for 6 months. Program B, same salespeople, different salary, larger commission for the next 6 months. Data shows how the amount sold in thousands of dollars for each salesperson on the program. So, find the differences, assuming group 1 equals program A. So the difference, you got to fill in these boxes right here. So 55 minus 53 is 2. 21 minus 24 is -3. So pay attention to whether you get a plus or a minus, okay, when you're subtracting these. So, all right. So fill those in. The above situation is an example of what? Independent, quantitative, dependent. Is it independent or dependent? Is it qualitative, quantitative? What do you guys think? Independent, quantitative. So, um, in order for it to be independent, that means that the 2 samples have no overlap, meaning it's 2 different groups of people measured once. Okay. So it says right here, so they list the salespeople as numbers here. But so like this could be, instead of writing it as salesperson 1, right, we could put Jack here and say, all right, Jack on program A for 6 months, he sold $55,000 worth of stuff. I don't know what they're selling, but that's how much he sold. And then when we switch to program B for the next 6 months, he sold 53,000. So it's the same person. All of these are there's 9 people, and it's the same 9 people for both programs. First 6 months, second 6 months. Okay. So it's dependent. Okay. Now, are we measuring qualitative or quantitative? We're measuring how much they sold, which is a number. So it is dependent quantitative. This one. We're measuring numbers. We're measuring how much did they sell. What's the average sales for your salespeople? Okay. All right. Can you conclude that the mean sales difference between differ between the two programs? We're doing a hypothesis test, and this is dependent, this is matched pairs. So what page will I find the StatCrunch buttons that I need to click for this? Jalen says page 265. I agree. Page 265 is mean. We're looking at the average sales for matched pairs, and that's what we have here. Matched pairs, and we're doing hypothesis testing. Okay. All right. That's all the hints for tonight. Let's go back to page 563.